So it's similar to your O-levels electrolysis. What happens here is that same thing. Whoever has the high E naught, it gains electrons, and whoever has the low E naught, it likes to lose electrons. Things are, I mean, it's exactly the same. It's what we've been doing, except there's one difference now between the electrochemical cell and electrolysis. Electrolysis uses an external power source, which is basically electrical energy. So you have a battery now. So what it does is it uses electrical energy and converts that into, or drives the chemical reaction using that. Now the cell was different. The cell was exactly the opposite. Like if you look at a cell, so cell you're not, there's a current flow that's happening because of a chemical reaction, that the higher potential one wants to gain electrons and the lower potential one wants to lose electrons. So there are two chemical reactions that are happening: higher gain kar, lower lose kar, and the electrons, they start flowing from the lower potential to the higher potential. So because of the chemical reaction, a current is produced. That is what an electrochemical cell or galvanic cell is. But over here, it's the exact opposite, that that एक power source होगी which is going to drive current through a circuit, and because of that current, a chemical reaction will take place. So it's the exact opposite of what we have discussed. ये draw करके मैं दिखा देता हूँ of an electrochemical cell. So first thing, if I do electrolysis, the first thing is you have a battery. So you already have a power source. The electrons are already moving in a certain direction. मतलब आपके reaction की वजह से वो move नहीं कर रहे, they're already moving in a certain direction. And there are two electrodes. One of them is cathode, the other one is anode. Okay, let's assume that at the moment they are both inert. ठीक है, ये हमारा दूसरा हो गया. So let's at the moment assume that they're made out of platinum or some inert material. As in you've dipped them in a solution, and the solution has ions or substances in it. So for example, let's do NaCl, and let's do, I'm going to start with NaCl aqueous. So let's say this is NaCl. Aqueous. Now NaCl aqueous means that the solution will have two ions. Now we've got a negative cathode. ठीक है, remember आपके reaction की वजह से electrons move नहीं करे, the electrons are already in motion, so the electrons are already traveling, and that's your negative cathode. And the other side is, so the other side is your anode. Which is positive. So you've got positive anode. As a cathode and anode, So what's happening at anode is the battery is driving electrons away from anode. So it's bringing in electrons. It's a solution. What do you have in solution? In solution, you've got ions. You've got Na+1, and you've got Cl ions. Now the positive ions are attracted to cathode. Because obviously it's negatively charged. So our positive ions are attracted to cathode, and the negative ions are automatically attracted to negative ions are attracted to anode. So Na+1 goes to one side, Cl-1 goes to the other side. Aqueous, what other things do you have in aqueous? Aqueous में और क्या होता है? Apart from sodium ions and Cl ions, what other things do you have? Seep, क्या होगा Risha? ठीक है, there's orals में क्या था? There's H and OH ions, right? So remember one thing that now the Morgan scheme is kind of very confusing on this, but technically there's very little H+1 and OH ions. Okay, so water doesn't really ionize a lot. So if you're talking about H+1 and OH ions, so very few. There's going to be very few H+1 and OH-1 ions. Very few of them, okay? कोई ज़्यादा नहीं होंगे, very few of them, and so not a lot. So remember, this water doesn't really ionize a lot. It just ionizes very, very. The concentrated maybe there's just going to be very few, okay? Depending if you've added H+1 or not. But water का अगर वो constant आप देखो Kw, that's very small. Like in pure water, the constant is the concentration of H+1 is 1 into 10⁻⁷ mole per dm cube. So what you can kind of assume is that water doesn't really ionize a lot. Although there is H+1 and OH ions, but not just, there are just very few of them. So instead, you've got water on both sides. Water is neutral. So water is at the cathode, and water is at the anode as well. The water is kind of present on both sides. Anode, cathode, dono pe. And now what it will try and do is, yahan pe kya hoga? What's going to happen over here is that the electrons are coming in from the battery. Somebody is going to gain those electrons. So it's either going to be Na+1, or it's going to be water that's going to gain electrons. So cathode pe kya hota hai? It's reduction. Only reduction happens. You can't have oxidation. So when you talk about cathode, read the equation in the forward direction. Because the reverse direction is not possible. If you're reading it from the data booklet, so jab ho gayi, there's only one option, that is gain of electrons. So you can't really. Kidhar gaya hamara data booklet? Just a second. So only reduction will be possible, which means that at cathode. So at cathode, the only thing that's possible is the forward reaction. So the only thing possible is forward. Sorry. Just a second. So opposite charge, the only thing possible is the forward direction. Okay, that's about it. At cathode. Okay, remember that. Only reduction, only forward direction. So anode way, it's going to be the opposite. It's the only thing that's possible is loss of electrons. Anyone who reaches anode, it's going to lose electrons. That's it. There is no other option available. The battery is going to take away electrons, and so only oxidation. So only oxidation, and the reaction and you're going to read the equations in the backward direction. All equations will be written in the backward direction. So who are your options? So if I open the data booklet, and if I look at the data booklet, there's Na plus 1, there's H2O, right? And they're going to gain electrons. So I'm going to look for equations where they gain electrons. So Na plus 1 and H2O, remember, only gain of electrons, only forward. The where's Na plus 1? Here's Na plus 1, that's gaining electrons, right? And I need equations for water gaining electrons. That's somewhere over here. Water gaining electrons. Where's water? Here's water. Here's water that's gaining electrons. That's about it. You got two equations. So I'm going to write both equations. Just give me 1 second. So Na plus 1 gaining 1 electron in equilibrium and forming Na, that's minus 2.71 volts. Of a water wali, you've got 2 water molecules gaining 2 electrons, and they're gaining 2 electrons, and it's forming H2 plus 2 OH ions. And this is minus 0.83 volts. So I've got these two reactions. तो वो दोनों मैंने लिख दिए वहां पे, यहाँ पे आके. So remember what I did here. SIF, gain of electrons at cathode, that's it. Forward direction. I mean, there's no reversible sign. And who likes to gain electrons? The one that has the only reduction, only forward. So who likes to gain electrons? The higher potential likes to gain electrons. So the equation I'm going to select is the one which has the higher E naught. Which in this case, if you look at the two equations, it's going to be the one, it's going to be this one. Okay, water is the one that's going to gain 2 electrons because it's the higher potential. It's got a higher tendency to actually gain electrons. Electrons वहां से आए. Water के पास भी आ सकते हैं, Na plus 1 के पास. So who's got the higher tendency to gain electrons? It's going to be water. High E naught, ठीक है? Is that clear? Isha, see, obvious is clear. अच्छा, फिर the other side. So remember, forget the reversible sign, okay? Only gain of electrons, only forward, okay? Only forward. Or दूसरी side पे, only oxidation, loss of electrons. So basically, we want them to lose electrons. So water losing electrons, Cl-1 losing electrons. Open the data booklet. Now I want them to lose electrons. Okay, backward के अंदर Cl-1 would be losing electrons. So I've got Cl-1 losing electrons, right? So that is 1.36, and I want water to be losing electrons. The water losing electrons, I've got this equation where I have water that's losing electrons. I've got another equation somewhere, जो कि ये वाली है water losing electrons, right? So I just want to look at the equation in the backward direction. I'm just going to copy those equations. Reversibly, I just want them to lose electrons. That's it. That's the only thing that's possible at anode. So पहले वाला कौन सा था? Cl वाला, वो देख लेते हैं पहले. It's 2Cl-1 arrow. So you had Cl2 plus 2 electrons, and that was, I think, 1.36 volts. ये मैं उधर बोर्ड पे लिख रहा हूँ. अच्छा, then so एक तो ये part हो गया. अच्छा, water वाली, two equations for water. That's 2H2O. And I've got as a 2H2O or H2O2 hydrogen peroxide. It's forming and 2H plus 1 plus 2 electrons. And the value is what? It's 1.77 volts. And then I have another one for water, that's 2H2O, and that's so that one is forming O2 plus 4H plus 1. And that is 1.23 volts. So that is 1 point. ये board के ऊपर मैं तीनों लिखती हैं. Although you don't actually have to write the equations on the board. Most of your working will be done. Achha, so who gets oxidized, who loses electrons? The one that has the lowest E naught. So यहाँ पे जो आप select करोगे ना, that's going to be the one that's got the. So that's going to be the one that has the lowest E naught. We lose electrons. That has the greatest tendency to lose electrons. The one that has the lowest E naught is the 1.23 volt equation over here. इसका change करने color. And that's it. You figure out higher E naught, you figure out lower E naught. That's it. Or you have the reaction there. So bas data booklet mein, all you have to be very careful about electrolysis is electrolysis you're not the one who's deciding who gains electrons, who loses electrons. Cathode ke upar, the battery is sending in electrons, so you've got only one option, and that is कि वो electrons gain ही कर सकते हैं. There's no other possibility. They can't lose electrons at cathode. They can only gain electrons. The reaction can only move in the forward direction at cathode. And who gains electrons? The one that has the higher E naught. So you're going to pick only those equations where they're gaining electrons, whether it's Na plus 1 or H2O. दूसरी side पे, you don't have an option. The only option you have is they're going to lose electrons. So you're going to try and find out equations where they lose electrons. Cl-1 water losing electrons. And who loses electrons? The one that has out of all of them, that has the lowest E naught. Okay? So ये clear है, ये reactions आ गए हमारे सामने. You got oxygen gas and you got hydrogen gas on the other side. Is that clear? So on both sides, you're going to be getting bubbles forming. That is what your observation is going to be. You'll see bubbles of oxygen gas, and you'll see bubbles of hydrogen gas on the other side. अच्छा बस ये बाकी है कि so you can pretty much do all electrolysis using this idea. मतलब ये करना है. If they ask you for the overall equation, what you can do is just add the two reactions up. Okay, if anyone is looking for the overall equation, add the two equations and simplify. Make the number of electrons gained and lost equal. तो दोनों लिखनी पड़ जाएंगी एक सेकेंड. There's 2 water plus 2 electrons. On the right side, arrow H2 plus 2 OH ions. And दूसरी side पे you got 2 water plus arrow O2 plus 4H plus 1 plus 4 electrons. I would have to multiply the first equation by 2, so this would become 4. This would become 4. This would become 2. This would become 4. So if I add them up, it's going to be 6 water molecules on this side. I'm going to have दूसरी side पे क्या है? अच्छा दूसरी side पे I'm going to have 2H2 plus O2 plus 4 OH ions and 4H plus 1. So that is what's happening. Okay, that's the overall reaction that's going on. Okay, just add the two reactions up. अच्छा अब इसके अंदर what can happen is कि यहाँ पे last time we did discuss in O-levels you also had this question, and the question is you're going to get a very specific question on this, specifically NaCl electrolysis, and that question is कि भाई अगर if NaCl is concentrated, so the question is why is chlorine produced? At anode. Okay, that's the question. Why is chlorine produced at the anode? You know this, that NaCl concentrated होगा तो chlorine gas is going to be produced. So question here कि why is that? The reason why that happens is if Cl, remember the potential difference between 1.23 and 1.36 is very less. And I told you last time that you can change the potential difference by changing the concentration. So agar, for example, if I have this, so इसमें ना Cl2. So remember this Cl2 Cl ion electrode potential, not the E0, the non-standard potential. It decreases when Cl is at a higher concentration. Is at a higher concentration. ये वाला जो reaction है Cl2 gaining 2 electrons in equilibrium with 2 Cl minus 1, which should be 1.36 volts, the standard potential. If you take Cl minus 1 at a higher concentration, the equilibrium would shift backwards. If this has a higher, if this has a higher concentration, the equilibrium will shift backwards. It's going to produce a lot of electrons, and the potential will decrease. So let's say we decrease, okay, it becomes 1.15 volts. So now, who's got the lowest potential? Like if I change the potential of the Cl2 electrode, instead of 1.36 at a higher concentration, it's 1.15. So who's the lower potential now? It's it's the Cl minus one that becomes a lower potential. So among all the reactions at anode, at anode, the Cl2, Cl ion electrode becomes the lowest potential. एक सेकंड में question. अब ये कि remember in O levels you had a question that if NaCl is concentrated, then it's not oxygen that is produced, it's Cl2 that is produced, right? So what I'm trying to explain here is कि why is chlorine gas produced? If NaCl is concentrated, why is Cl2 produced? So ये हमने वो last time किया था. I told you that if you change the concentration of the Cl ions in this equilibrium, if you take it to a higher concentration, the equilibrium shifts to the left. If it shifts to the left, the potential, the non-standard potential, will become lower. वो ज़्यादा electrons produce हो जाएंगे ना. ये हमने पहले last class में किया था कि if the equilibrium shifts to the left, at the electrode, more electrons are released, and the potential will be lesser. It will be more negative, right? So instead of 1.36, it's going to be, let's say, 1.15. तो आपका potential जो है वो change हो जाता है if you change concentration of substances. वो बात clear? Is that clear? So if the potential changes, let's say it's not 1.36, let's say it's 1.15. So तीनों में who wants to lose electrons? It's going to be Cl minus one. That's got the lowest E naught. Is that clear? So at a higher concentration, the potential of Cl, I mean, this electrode 1.36, it's not going to be 1.36. 1.36 is the standard potential. So it's going to be a different potential, which would be much lower. 1.15 hoga, तो तीनों में it's going to be, the Cl2 equation will be the one that has the highest tendency to lose electrons. So you get a question on this. Now that is not an issue. I say यहाँ पे the reason why you have an issue with Cl2 is okay, the potentials are very close. It's 1.36, this is 1.23. So if you change the concentration just a tiny bit, so the lower becomes the higher and the higher becomes the lower, right? वो lowest E naught जो है ना वो change हो जाता है, ठीक है? It's not an issue at anode because there's a huge difference between the potentials. Like even if you change the concentration, the higher one will still be a higher because almost 2 volts ka fark hai. That's too big a difference, right? So you don't really have that much of a difference between potentials in other reactions. Over here, you've just got a minor potential difference. So just a minor change in concentration and the substance that gets discharged at anode changes. ठीक है? ये clear बात? So ठीक है, बस फिर next time discuss करते हैं. बस इसको simple रखना है, ठीक है? Forget the equations. Just remember, like keep it simple. Paper के अंदर you don't have to, I mean, do all of this work. You just have to. You don't even have to probably draw the diagram. All you have to know is what is that anode gains electrons. Who gains electrons? The one that has the high E naught. Open the data booklet. Try and figure out equations where they're gaining electrons. Just the forward direction where they gain electrons. Figure out who has the high E naught. दूसरी side पे who's at anode? They want to lose electrons. Who wants to lose electrons? The one that has the lowest E naught. Try to figure out equations in the backward direction. ठीक है, where they lose electrons. तो इसमें equilibrium वाली बात नहीं है. Cathode they gain electrons, anode they lose electrons. So let's we'll do some more examples. That's about it. That's electrolysis. We'll do more examples. Actually, remember what electrolysis is. Like if the question is not that big, you can just repeat your O-level stuff. So we'll next class में थोड़ा सा O-level का भी कर लेंगे. O-level में क्या होता था? You had a यानी अगर वो कह देते ना NaCl concentrated, all you had to do was ठीक है Cl2 is discharged. That's it. So if the question is not asking, it's just a 1 mark question. Just remember the O-level stuff. The NaCl concentrated, Cl2 is discharged. ठीक है. If they go into details and they want an explanation for that, then all of this would be required. So ठीक है, next class में बात करते हैं. ठीक है. चलिए, ओके, अल्लाह हाफिज़.